Hi, we're going to do an example of a z-test, a hypothesis test for the mean using z. We're going to do it by hand, and then we'll do it in StatCrunch. This is a problem that came from a test I gave a while back. This is a problem from my own life. My husband is determined to get a mullet, and so I keep telling him, as soon as you get a mullet, your IQ drops. So I made up this problem to prove that I'm right. So we know that IQ tests are calibrated so that the population mean is 100 and the population standard deviation is 15. So according to this example, they took a sample of 25 people, so that's the sample size 25, who have mullets, and they get a mean IQ of 87.2. So assuming alpha equals 0.05 and using that population standard deviation of 15, test whether people who have mullets have a mean IQ below the general population. First of all, let's point out why this is a z-test. Well, we know here the population standard deviation. Okay, that right there makes it a z-test. And here we actually should either have a sample size greater than or equal to 30 or know that we're sampling from a normal distribution. We're not actually told that here, but IQ tests are normally distributed. So we'll just suppose we know that. All right, so here we have two hypotheses, as always. We have a null and an alternative, so HA or H1. And the alternative hypothesis is that people who have mullets have average IQ below the general population. So below is going to be mu less than. The general population is 100. So that means that the null hypothesis is mu equals 100. So now, you know that the formula for the z-test statistic is x bar minus mu naught over sigma over the square root of n. And I realize that looks like an alpha, but that's x with a bar on top. So if we plug in here, x bar is 87.2. That's for the population, or for the sample. So 87.2 minus the population mean, or the hypothesized value, is 100, over sigma is 15 over the square root of the sample size, which is 25. So if we plug this into the calculator, we get 87.2 minus 100 divided by 15 over the square root of 25. And we know that's going to be 3, but we'll still do it. So we get negative 4.2667, so negative 4.27. So that's our test statistic. And now to find the p-value, that's going to be the probability that z is less than negative 4.27. And now keep in mind that the sign here in the alternative hypothesis is what determines this sign here. So less than here means less than here. Greater than in the alternative also means greater than in the p-value formula. So if we look that up on our t-table, we know that that's essentially 0. So anything to the left of negative 3.49, we can call that 0.0001, because that's really the closest thing we have to it. So 0.0001. And as always, we're going to reject H naught if the p-value is less than alpha, which in this case is 0.05. So our p-value, 0.0001, is indeed less than 0.05. Therefore, we're going to reject H naught and say that there is indeed sufficient evidence to conclude that mu is less than 100. Which is not a surprise, since I made up this problem and I wanted to show that having a mullet makes you have a lower IQ. So indeed we can prove, based on this data that I made up, that the population mean for people with mullets is less than the IQs of other people. Okay, so that's how to do that by hand. Let's go over to StatCrunch and do it over there. All right, so in StatCrunch, we're going to go to, make this window the right size, ztest, just like we did with the confidence intervals. One sample with summary. Sample mean, I believe we said was 87.2. Let me check. Yep, 87.2. The standard deviation we're using is 15. Sample size is 25. And we're testing mu equals 100 versus mu less than 100. So we change that. We go to compute. And this is what we get, which is the same as what we got before. We got a test statistic of negative 4.27, and we got a p-value 0.0001. So we'll go over here and we'll paste this back in. And here you don't have to write out the hypotheses because they've got that written out for you. Mu equals 100 versus mu less than 100. It gives you the test statistic and the p-value. So all you need to do now is reject H naught if p-value is less than 0.05, and then say therefore, because the p-value is less than 0.05, reject H naught. There is sufficient evidence to conclude that mu is less than 100. In other words, that people with mullets have lower IQs than the general population. All right. So that's it. That's how you do it. It'll specify in the problem, by the way, whether they want you to do it by hand or using StatCrunch. So you don't have to do it both ways. All right. So that's all you have to do.